Welcome to Study Loop.
So to start this problem off, we're going to do a free body diagram. So we have A, we have a force at C going in the y direction. We have a force at B going in the y direction. And we have 400 pound per foot. £3,200 downward at A. And we do the moment at C. And it is 400 times 20 times 10 plus 3,200 times 22.5 minus b in the y direction times 20 equals 0. And solving for all of this, we get b is equal to 7,600 pounds. Then we could do the sum of forces in the y direction. We do negative 400 times 20 times 10 plus 3,200 plus 7,600 plus c in the y direction, and we get c is equal to 3,600 pounds. We can then look or do our shear force calculations. And we can look based on the points A, B, C, we would look on the left and the right of it. So VA on the left side is going to be 0. And VA on the right side is going to be negative 3,200 pounds. VB on the left is negative 3,200. And on the right, we have negative 3,200 plus b in the y direction, which we solved for. And that is equal to negative 3,200 plus 7,600. And we get 4,400 pound. Then we have C in the left direction. This is negative 3,200 plus b in the y direction minus 400 times 20. Solving for that, we get negative 3,600 pounds. And if we look in the right direction of C, we have negative 3,200 plus b in the y direction, 400 times 20 plus cy. And all of this ends up equaling to 0. Now we can do the bending moment calculations. MA is going to equal to 0, and moment at B is equal to negative 3,200 times 2.5, which is equal to negative 8,000 pound-foot. Then we can find the moment at C, which is negative 32 times 22.5 plus B in the y direction times 20 minus 400 times 20 times 20 divided by 2, and that's going to be equal to 0. which we anyway solved for over here. So now we can do the shear force and bending moment diagrams. And so I'm just going to copy this. So we have a straight line down here. So based on the shear forces we had calculated, we have, let me label this also. This is pound, this is A, B, and that's C. So we come down to negative 3,200. Then we're going to go up to 4,400. And then we go to negative 3,600. And I'm going to say that this between, let's see, from here to here, or sorry, let's say 20 minus D, and this is D. So for our moment diagram, we're going to get we have negative 8,000 and coming up here we have 16,200, and then we come back down to 0. So to calculate the location for our maximum moment, we do 4,400 over D equal to 3,600 over 20 minus D. And we're going to calculate the value for D. So you would cross multiply, and out of that you will get D is equal to 11 feet. And D is the location of zero shear force. So to calculate, we're going to do X equals 2.5 plus D. And we're going to substitute 11 feet here. So 2.5 plus 11 equals 13.5 feet. And that's our location for our maximum moment. To calculate the magnitude of the maximum bending moment, we do, or actually, M max is equal to negative 3,200 times X, which is 13.5, B in the Y direction, times D, minus 400 times d times d over 2, which we get negative 3200 x d minus 200 d squared. And once you substitute for 13.5 feet, 11 feet, we get 16,200 pound-foot. And that's our magnitude of maximum bending moment.